Okay, let's go ahead and take a look at spheres, and we're going to do the surface area and the volume. Spheres, out of all of the objects, they really only have one characteristic. You can see that both the surface area and the volume are really functions of the radius, meaning they only depend on the radius. Like a cylinder depends on the radius and the height. A pyramid depends on the base and the height and the slant height and all those things. Spheres are the easiest ones probably because they're so formula based. The surface area is 4 pi r squared and the volume is 4/3 pi r cubed. Easy to keep track of. The squared one, of course, has to be surface area. Squared is going to give you square dimensions, where the cube is going to give you cubic dimensions, and that's what a volume is, right? Three-dimensional space is like cubic inches, where two-dimensional space is like square inches. So if I just give you a sphere, okay, and I give you the radius, let's say, is 6, right? So then the surface area is just 4 pi times 6 squared. Lots of times we'll just do 4 times 6 squared, and we'll leave it in terms of pi, and we'll get 144 pi, and again, that might be like square inches, right? The volume is going to be 4/3 pi r cubed. And it doesn't matter. You can do 4 times 6 cubed and then divide by 3. Most of the time on my calculator, I'm going to do 4 divided by 3 times 6 cubed. And that's going to be 288 pi cubic inches. Now, if you were doing a story problem, maybe you turn this in to a decimal and actually do 144 pi and, report 452.4 square inches. But lots of times we're going to leave it exact with spheres, cones, and cylinders, anything that kind of involves pi to it. I could go backwards on something like this to make it a little more difficult. What if I told you the volume of a sphere that I had was 100 cubic inches? Could you actually find the radius? You're like, okay, well, if I know the volume is I know the volume is 4/3 pi r cubed, and if I happen to know that I created a sphere with an exact volume of 100, I can just put 100 in for v. This particular one, I'm going to go ahead and take 4/3 a pi and get a number for that, just so I think it's a little easier algebraically. 4.189 r cubed. Then I'm going to take the 100 and I'm going to divide by that and get 23.87. And then I'm going to take the cube root. The cube root is taking 23.87 to the 1/3 power. So you want to raise that to the 1/3 power, and you're going to get a radius of 2.88, and that would be in inches. Okay, so clearly I could give you the radius and you could find the surface area and the volume, or I could give you the volume of a sphere and you could go ahead and find the radius, or I could have done surface area and you could have done the same thing. You would have set whatever the surface area, you would have set equal to 4 pi r squared. You would have found 4 pi, you would have divided, and then you would have took a square root. Probably the hardest thing is remembering to take the cube root. Remember, the cube root of something, this step, when I wanted to take the cube root, I raised that to the 1/3 power. So I did on my calculator 23.87 caret 1/3. Okay, and that's where that 2.88 comes from. And there'll be other challenging questions you do. Maybe you're going to take a sphere and chuck it inside a cube. Maybe something like this. Put that sphere inside of this and decide how much space is left, or things like that. But I'll let you explore a little bit on your own. But in general, spheres are pretty easy and they abide by those two formulas.